Okay, this video talks about how to find the greatest common factor of polynomials. All right, the first thing you want to think about is that what is factoring? Basically, factoring is the reverse of either multiplying, distributing, or foiling. So instead of having something in its most complex form all put together, you actually are looking for what it would be in the simplest form if you broke it up into the smallest parts. For example, when you multiply 5x times this binomial, you would distribute the 5x to each term, and this is what you would get. This is the foiled or the multiplied form, the most complex version. But the factored form actually goes backwards. And so what we want to do is kind of like a puzzle. We want to try to figure out what were the things that you multiplied together to get this. So in factoring, you're going to start with the thing that is already put together, the parts that have already been multiplied together, and you're going to try to end up with the individual parts. So how do you do that? How do you know what was multiplied together in order to get that final polynomial? So in general, you start off by looking for a greatest common factor. That means what is in common with every single term. What was the same for every term? And so you start looking for that. So you're looking for something that if it was the same in each term, you can pull it out of each term, because if you pull it out like this, then when you were to multiply it back again, it would come back together to be what you originally started with. So anyway, okay, so basically when you're multiplying, it looks like this. You take something and you multiply it by each part. But when you're factoring, you're looking for a common part and you're pulling it back out and then multiplying it, but on the outside. So you look for numbers or variables or both that are in common with both terms, and you divide it out. And then remember that whatever variable you take out has to be the lowest number, the lowest exponent of that variable. So you can't take out more than what you have. For example, in this term, what's in common with 6 and 10? Well, I know I can divide 6 by 2 and 10 by 2, so I can take a 2 out. Also, what's in common with x cubed and x squared? Well, I can't take out 3x's because there's only 2 in this term. So I can only take out the least number of variables. So I can take out a 2 and I can take out 2x's. If I take it out, what's left? Okay, if I take a 2 out of a 6 divided by 2 is 3. And an x cubed divided by x squared means there's an x left. So when I'm dividing it, I should be able to multiply my answer and get back to the original question. So here, if I take a 2 out of 10, I have 5 left. And if I have x squared and I take x squares out, I don't have any x squares left. So this is the factored form, and this is the multiplied form. Okay, so when you look, this is how you would write it out. You would say, okay, I can take out a 2 of both, I can take an x squared of both, and you divide each term by the same amount. You factor that out. You can't throw it away because there's no equals or anything. You factor it out or you pull it out. Now, when you pull out the greatest common factor, you should be able to multiply it back and get the same thing that you started with. You're not changing what you have, you're just changing what it looks like. So you're breaking it down into its individual parts. For example, if you have the number 12, the number 12 is the same as the numbers 3 times 4, which is the same as the number of 3 times 2 times 2. This would be like having the factored part because it's the smallest parts. This is still equal to 12. This is still equal to 12, and this is equal to 12. But what we're trying to do here in polynomials is we're taking our larger polynomials and we're breaking them up into smaller parts. Okay? All right, so let's do a couple more examples where there's some various things thrown in here. All right, so let's look at this one. So the first thing you look at is the numbers, the coefficients. So what can be factored into 15 and 9 and 27? Well, off the top of my head, I think, well, this can be divided by 3, this can be divided by 3, this can be divided by 3. So if I divide all of these terms by 3, I can end up with something that has 3 on the outside, and then 5, and negative 3, and 9. Okay, so that'll give me the coefficients. Now, what about the y's? Okay, so I have 5 y's here, 4 y's here, and only 3 y's here. So if I want to divide them all by y, I can only divide them by the lowest coefficient. So I can only take 3 y's out. Well, if I take 3 out, I have 2 left. And if I take 3 out of here, I have 1 left. And if I take 3 out, I have no more left. Okay? So you can factor it out that way. So you end up with something that looks like this, and you put your greatest common factor outside. Okay, again, because if you FOIL this back out or distribute this back out, you should end up with the same thing as that you started, because all you're doing is taking this larger polynomial and you're breaking it into its smaller parts. So 3 times 5 will give you 15. The y cubed times y squared means there's 5 y's all being multiplied. Distribute all of the terms and you should get the same answer. You can always check your answer, okay? So, since factoring is the reverse of multiplying, you can check your answer by just multiplying it back out. Yes, I did that, and I noticed that it gives me the same thing I started with, so that means I did it correctly. Okay, so if you look at this one, I've already kind of shown you part of the answer, but you're looking for the most number of x's that you can factor out and the most number of y's, because all of these terms have x's and y's. So this is my original polynomial that I started with. And when it says factor, that means break it up into its smaller parts. How many x's can I get out? Well, only 3, because this one, that's the most this term has. Remember, whatever I factor out has to be factored out of every single part. Anything that's divided by an addition sign or subtraction sign. Also, my y's, the most y's I can factor out are 2, because that's the most I have in the last term. So I'm going to divide each term by the same amount. Now in this case I only wrote it once, but really this is being divided by this denominator, this one and this one. All 3 are. So it's just like this one up here. I just wrote the denominator once instead of 3 times. So when you work it out and you divide each part, this is what you get. Be careful. A lot of students forget this 1. They'll say, okay, x cubed and x squared over x cubed and y squared, excuse me, cancels, and so they think, oh, cancel means 0. It doesn't mean 0. It means that something over itself is 1. So basically you would remultiply it out to make sure that your factored form will go back and give you what you started with. Okay? Now when you look at what you have, you can't actually do anything else with this. You can't simplify it anymore. There's no combining like terms or simplifying anymore. That's as simple as it gets. Okay, now you try. So pause the video and try those in earnest, because that's really the best way to know if you understand how to do these concepts. All right, now these are the answers. So hopefully you found what was in common. Okay, now we're going to keep going. We're going to look for something called the greatest common factor, but what if there's a negative coefficient? In other words, we always want to have it so that we don't have negatives in the front of our polynomials, okay? So if we have a -5, we're going to want to factor out a -5 out of both terms. Be careful, because when you divide a negative by a negative, you're going to get a positive, but when you divide a positive by a negative, you're going to get a negative. Okay, so this -5 divided by -5 is +1, and I get an x squared left over. 30 divided by -5 is -6. I can't throw away my -5, remember, because whatever my answer is, it has to be the same equivalent to what I started with. If I had left out the -5, this polynomial and this polynomial are not the same. But by keeping the -5 that I factored out, when I multiply this out, I actually have equivalent polynomials from when I started to when I factored. Okay, so I want you to try this one. Be careful about these negatives. Look at your variables. Okay, I notice that you can take out a -3, 2 A's, and a B, and when you factor all those out, this is what you get. And again, you can distribute the answer that you got, the factored form, and determine that yes, you have the correct answer. So look at the next one. If you take your greatest common factor of -4, only 1 A and 2 B's, this would be your answer. Again, we can't just throw away what we divided by. We have to keep it so that our final answer that's in factored form is the same value as the original polynomial that we started with. Okay, so let's keep going and let's talk about factoring by grouping. When you're factoring by grouping, that means you want to put sets together that match. So if I had something like this where an x squared with an a and a 5 with an a, I say, hey, I have a common factor here. I have an a and an a, so I could pull my a out. I could put it at the end or at the beginning. It doesn't really matter. And I'm left with x squared and I'm left with 5. So it's the same idea. The difference here is that this a that we talked about down here is just a whole binomial. So x squared times something plus 5 times something. These two somethings are the same. They're like my a's. So I can factor them out like this. Okay? So looking here, again, there's a y plus 1 in common with both of these terms because they're being multiplied, x times something minus 2 times something, and these two are the same. So I can pull the y plus 1 out and I'm getting x minus 2 left over. Now, I want you to notice that whenever I get my answer, if I were to distribute this, I could get the same thing. So x times y plus 1 minus 2 times y plus 1, because we could write this way as well. All right, so we could say x times y plus 1 minus 2 times y plus 1. The whole thing is what we're looking at. This is a unit, okay? Then you would get the same as what you started with, okay? So try looking at these and see if you can find two binomials out of each one. So here you're going to factor out the x plus 1, and here you're going to factor out the y plus 4. Hopefully this is what you got. Okay? So what are the steps? Okay? So basically when you're factoring by grouping, you want to group all the terms that have some kind of common factor together. There's usually two groups. And sometimes you might have to rearrange them, move the two things together that you want. You want to factor out the common monomial factor. Monomial just means it has a coefficient and a variable of some sort or more. And then factor out the remaining binomial if it exists. So let's look at what that means. Okay, so here I've got something with an x and a y, a 5 and an x, a negative 4y, and a negative 20. Well, I want to group them into sets. Okay, so in these two terms, I have an x in common. In these two terms, I have a negative 4 in common. So I'm going to go ahead and get the x out of this one. Okay, and then I'm going to take the negative 4 out of this one. Keep it in mind that I'm going to divide each one by negative 4 just like I did before. Okay? So now I have two parts. This is all still together. I just kind of wrote it separately because I'm doing it separately. All right, so now I have the same thing as what I had on the previous page. I have an x times something minus 4 times the same thing. So this would be like x times a minus 4 times a. So that means that I can take x minus 4 out and a out, which happens to be a binomial. Now, if you were to, using the box method, if you were to FOIL this all out, you would end up getting the same polynomial that you started with, xy plus 5x minus 4y minus 20. So it's the same factor. All right, so I want you to look for sets of two, put them beside each other, and then try it. Okay, so try these two in earnest, and then check your answer. Okay, so hopefully you noticed what was in common. All right, now I want you to try these two in earnest, and then check your answers. This one was a little tricky because you kind of had to rearrange them. Well, it worked best. The goal for factor by grouping is that each piece is multiplied by the same thing. You want to have something multiplied by the same thing as the other thing multiplied. So these two must match, which is why I rearranged these so that my 4x minus 1s would match. Okay, good luck.